Hello class, in this video we shall be discussing on another property of the colligative property, so that is osmotic pressure. Okay, so let us first see what is osmosis, then comes to diffusion, and later on we shall go to the osmotic pressure. Okay, so the phenomenon of the flow of solvent through a semi-permeable membrane from pure solvent to the solution is called osmosis. Let us try to differentiate between the osmosis and diffusion. Okay, so in case of osmosis, the solvents will need a semi-permeable membrane, whereas in diffusion they don't need, or they don't have. Okay, for diffusion they don't have semi-permeable membrane. Okay, it is only the movement of solvent in case of osmosis, whereas in case of diffusion it is both the movement of solute as well as solvent. Then the movement of solvent will take place from, in case of osmosis, it will take place from lower concentration to higher concentration, and diffusion will take place from higher concentration to lower concentration. Okay, then in case of osmosis it is limited only to solutions, whereas in case of diffusion it is found even in gases as well as liquids. Okay, then we shall go to the osmotic pressure. Osmotic pressure is the excess of pressure which is required to prevent the flow of solvent through the semi-permeable membrane. So it will prevent the flow of solvent into the solution through the semi-permeable membrane. So the amount of pressure needed is called the osmotic pressure. Okay, so let us go to the next one, that is the Van Hoff. Okay, Van Hoff equation. According to Van Hoff, for dilute solutions, the osmotic pressure is given by, osmotic pressure is denoted by pi. Okay, so pi is given by CRT. Okay, where C is the molar concentration, that is molarity. Okay, R is a gas constant. Okay, and T is the temperature. Now if we are asked to find out or determine the molar mass of the solute from the osmotic pressure, then we can find out like this, that is, we know that C is equal to number of moles by volume of solution. Okay, and again number of moles is equal to mass of solute. Okay, this one is number of moles of solute, isn't it? So will be divided by molar mass of solute. So this one will be C equals to WB by MBV. Okay, so instead of C we can write WB RT divided by MBV. Okay, this is how we can express. Okay, and that way we can find out the value for molar mass through this osmotic pressure. Okay, let us now try this numerical problem, that is 200 centimeter cube of an aqueous solution. Okay, centimeter cube means ml. Okay, so of an aqueous solution of a protein contains 1.26 gram of the protein. Okay, so let us first try to write down the given values. Okay, so this 200 centimeter cube of an aqueous solution, that means the volume. Okay, the volume of the solution is equal to 200 ml. Okay, this is what it is given. Then we convert this 200 ml into liter, so it will be 0.2 liter. Okay, we divide it by 1000 and it will be 0.2 liter. Then the mass of the protein, 1.26 is the mass of the protein, so we write WB is equal to 1.26 gram. Okay, the osmotic pressure of such a solution at 300 Kelvin, that means the temperature is given 300 Kelvin, is found to be 2 point. This is the value of the osmotic pressure. Now we know osmotic pressure is pi. Okay, which is 2.57 into 10 to the power minus 3 bar. Okay, and the value of real gas constant is given by 0.083 liter bar mole inverse, Kelvin inverse, and we are asked to find molar mass of the protein. So we know it's already here, okay, the formula, that is WBRT by pi V. Okay, so we just have to change the values, substitute the values. Okay, so WB is 1.26 multiplied by R is 0.083 multiplied by temperature is 300 divided by pi is 2.57 into 10 to the power minus 3 multiplied by volume is 0.2. So after solving this one, we shall get around 61039 gram per mole. Okay, this is the value we will get. Okay.